14, page number 14 in your textbook. Okay. The first question, which of the following statements about the reaction below are incorrect? The reaction is 2PbO plus carbon. Okay, we get 2Pb plus the carbon dioxide gas. So what we have options, lead is getting reduced, carbon dioxide is getting oxidized, carbon is getting oxidized, or lead oxide is getting reduced. Which options, one or two correct? Like that he is asking, maybe multiple answers may be correct or it may be incorrect also. So what are the, he is asking about the incorrect option. He is asking A and B correct. Because lead, he is telling lead is getting reduced. Lead is not reduced. No, lead oxide is reduced. So first option, it is incorrect. Next one, carbon dioxide is getting oxidized. Carbon dioxide is not oxidized. Carbon is oxidized. So option 1 and 2, okay, are incorrect. They are incorrect. Next one, Fe2O3 plus aluminium, we get Al2O3, aluminium oxide plus iron. Aluminium oxide plus the iron. Okay. So what he is asking, the above reaction is an example of, it is an example of what type of reaction? Displacement reaction. Correct. Because aluminium is displacing iron here, so it is a displacement reaction. Displacement reaction. Third one, what happens when dilute hydrochloric acid is added to the iron filings? Dilute hydrochloric acid means what? HCl. When you add it for iron filings, what do you get? FeCl2 plus hydrogen gas. Okay. Here we get FeCl2. Why it is FeCl2? Because iron valency 2, chlorine valency 1. Cross multiply, 1 iron reacts with 2 chlorine to form FeCl2. Okay. And it is an, yeah, iron will displace hydrogen here. Iron will displace hydrogen. It is an example of displacement reaction. Okay. What is asking? Hydrogen gas and iron chloride are produced. Yeah, first option it is correct. No, chlorine gas and iron hydroxide are produced. Second is wrong. No reaction. Fourth one he has given iron salt and water are produced. So first option is correct. First option is correct. That is hydrogen gas and iron chloride is produced. Okay. Atoms of every element in the product. See what, how many atoms you will put in the reaction, that many atoms should be there, right? Even in the product. So then it will be balanced. Okay. So that is why we have to balance the chemical equation. Write down that. The number of atoms of every element, the number of atoms of every element of the reactants is equal to number of atoms of every element of the product of the product. So why we have to balance? Because when you balance the equation, what happens? It holds good the law of conservation of mass. Law of conservation of mass. It validates. It validates the law of conservation of mass. Conservation of mass. Okay. Then next, translate the following statements into chemical equation and balance them. First one, what they have given: hydrogen, hydrogen gas combines with aluminium sulfate. With aluminium. Okay, different question I'm getting. Sorry. Okay. Uh, hydrogen gas combines with nitrogen to form ammonia. To form ammonia. Okay, hydrogen gas combines with the nitrogen to form ammonia. So hydrogen combines with the nitrogen to form ammonia. Ammonia is NH3. Nitrogen valency 3, hydrogen valency 1. So one nitrogen combines with three hydrogen. One nitrogen combines with three hydrogen to form ammonia. And ammonia, where do we use ammonia? Ammonia we use in pesticides and all, right? Fertilizers also we use ammonia, right? Urea and all contains the ammonia there. There it is used. Okay. Balance this equation now. Balance this equation. Here nitrogen 1, here it is 2. So we have to make it as 2NH3. 2NH3. Now nitrogen is balanced. Hydrogen 2 here, here it is 6. So I will make it as 3H2. It will be balanced. Hydrogen sulfide. Hydrogen sulfide. Hydrogen sulfide gas burns in air. Burns in air to give water and sulfur dioxide. To give water and sulfur dioxide. Write the equation for this. Try. Listen. Here, hydrogen sulfide. Hydrogen sulfide is H2S. Okay. Hydrogen sulfide is H2S. Now, burns in air. In earlier also I have told that burns in air means it is combining with the oxygen. Correct. It is combining with the oxygen. Wherever you get burns in air means it is combining with the oxygen. So it is O2. Okay. Burns means what? It is heated. Correct. Hydrogen sulfide burns in air, we get water and sulfur dioxide. Water formula is what? H2O plus sulfur dioxide SO2. Yesterday, I think, no, we saw SO2 is sulfur dioxide. We wrote it, right? Like that. And sulfur can have different valency. Sulfur can have different valency. Okay, like we have sulfur dioxide, sulfur trioxide, like that. Here they have given sulfur dioxide, so SO2, and SO2 is a gas. This is a liquid. Okay, H2S is also a gas, and oxygen is also a gas. Clear? So whenever they give, it is burning with air. That means it is combining with the oxygen. Hmm? Next, try this one. Barium chloride. Barium chloride reacts with aluminium sulfate to give aluminium chloride. Aluminium chloride and a precipitate of barium sulfate Try this. What did you get? See, barium chloride. Barium, Ba is the symbol. Listen, barium, Ba is the symbol. Okay, chlorine Cl, barium valency 2, chlorine valency 1. So one barium reacts with two chlorine. You will get BaCl2 plus aluminium sulfate. Sulfate as a group, it is SO4. Always remember sulfate, wherever sulfate is there, that is SO4 is the group. Okay. SO4, listen here. Sulfate as a group, it is SO4 and its valency is 2. Okay, its valency is 2. So aluminium sulfate, aluminium valency 3, sulfate valency 2. So you will get 2 aluminium reacts with 3 sulfate group. So Al2SO4 thrice. We get aluminium chloride, aluminium valency 3, chlorine valency 1. So we get AlCl3 plus precipitate of barium sulfate. So barium valency 2, sulfate valency 2. So 2 barium reacts with 2 sulfate, or 1 barium reacts with 1 sulfate group. So you will get BaSO4. Okay. BaSO4, it's a precipitate. BaSO4 is a precipitate.
Should we put an arrow mark for the precipitate?
No, no, arrow mark we will put for the gas. So you're telling this down mark you want. You're trying to tell this one, down mark. That you can put. It's a precipitate. And what will be the color of the precipitate? It is white. White. Okay, barium will be white. So you will get white precipitate. Metal, potassium metal reacts with water. With water to give potassium potassium hydroxide and hydrogen gas. Write the equation. Potassium metal, what is the valency of potassium metal? 1. Some mistake is there. Just check.
But if they are given only copper chloride, not toothpaste or cookware, so should we take copper valency as 1 or 2?
Copper chloride, CuCl2 only, no?
But they haven't mentioned if it's toothpaste or cookware.
CuCl2 only, okay.
No.
Correct.
If it's only copper, it's one way. If it's only copper.
It's two, no, many times.
But the copper has both valencies.
Correct.
So which one should
Most of the time it is two. Copper oxide, CuO, you will take. Yeah. What did you get here? Potassium metal. So K. Potassium symbol is K, right? And its valency is 1. Okay. Potassium metal reacts with water. So it is H2O. You will get potassium hydroxide, KOH. Yesterday we studied, right? OH is hydroxide group. OH is what? Hydroxide group, and its valency is 1. So you will get potassium valency 1, hydroxide as a group valency is 1. So you will get it as KOH. Okay, plus hydrogen gas. Plus the hydrogen gas. This is solid, this is liquid, and here it is aqueous. It's a chemical equation for the following reactions. Okay, calcium hydroxide, calcium hydroxide plus carbon dioxide, carbon dioxide. When calcium hydroxide reacts with carbon dioxide, we get calcium carbonate. Calcium carbonate plus the water. Write the equation. You are understanding? So, listen once. Calcium hydroxide. Calcium symbol is what? Ca. Right? Calcium valency 1, hydroxide. Sorry, this is 2. Calcium valency 2, hydroxide it is 1. So you will get 1 calcium reacts with 2 hydroxide group, CaOH twice, plus carbon dioxide CO2. You will get calcium carbonate, CaCO3. Okay, CaCO3 plus water. Carbonate means CO3 group. Wherever carbonate is there, that is CO3 group, and valency will be 2, and its valency is 2. Okay, so you will get CaOH twice plus carbon dioxide, CaCO3 plus H2O, and it is already balanced equation. Okay, the first one. Next, second one, zinc plus silver nitrate. Zinc plus silver nitrate, we get zinc nitrate plus silver. Write down the equation for this. Zinc Zn, silver 1, zinc 2, silver 1, zinc 2. Next, what you will get? Zinc Zn plus silver nitrate, Ag nitrate group NO3. Okay, zinc valency 2, silver valency 1. Okay, nitrate also 1. You will get Zn plus AgNO3. Zinc, we get zinc nitrate. Zinc reacts with silver nitrate, we get zinc nitrate. ZnNO3 twice. Because NO3 valency 1, zinc valency 2. So we will get ZnNO3 twice plus silver. That is 8. Okay, what type of reaction is this? Yeah, correct. Displacement reaction. Zinc displaces silver in silver nitrate. Next. Next one. Aluminium. Aluminium plus copper chloride. Aluminium plus copper chloride. We get aluminium chloride. Aluminium chloride. Okay. Aluminium chloride plus copper. Aluminium Al plus copper chloride. We get aluminium chloride. So what is the formula for copper chloride? Cu chloride CuCl3 actually. Okay, you are asking about this, right? Okay. Aluminium chloride will be AlCl3 plus the copper. Okay. Barium chloride, next one. Barium chloride plus potassium sulfate we get barium sulfate. Plus potassium chloride. What type of reaction is this? Double displacement reaction. Correct. Barium is displaced by potassium and potassium is displaced by barium. So it's a double displacement reaction. So barium chloride, barium valency is what? 2. Chlorine valency 1. So BaCl2 plus potassium sulfate KSO4, K2SO4 you will get. Because potassium valency 1, sulfate 2. So you will get K2SO4. When they react, you will get barium sulfate, that is BaSO4 plus potassium chloride, that is KC. Okay, you have to balance this equation. So how to balance? Barium, chlorine, you have potassium, sulfur, oxygen. This is the reactant, and product also we have barium. You should have the same elements, right? Barium, chlorine, potassium, sulfur, oxygen. Barium you have 1 here, chlorine 2, potassium 2, sulfate 1, sulfur 1, oxygen 4. Here 1 barium, 1 chlorine, 1 potassium, 1 sulfur, 4 oxygen. Here you have 2 potassium, right? Here you have 1. So we can make it as 2 KCl. BaCl2 plus K2SO4. We get BaSO4 plus 2 KCl. We have not changed anything in the reactants. Barium valence, here it is 1. Potassium 2. And chlorine also. Remaining will be the same. Yeah, it is balanced. Okay, next. Done? Huh. Any doubt? Okay. This is done. It is a double displacement reaction. Next one. Write the balanced chemical equation for the following and identify the type of the reaction in each case. First one, potassium bromide, potassium bromide, okay, potassium bromide plus barium iodide, plus barium iodide. We get potassium iodide. We get potassium iodide plus barium bromide, plus barium bromide. Potassium bromide. Potassium means what? K. Bromide is that. That is bromine. So both the valency is what? 1. So you will get KBr plus barium iodide. Iodine, what is the valency? 1. Barium, 2. So you will get BaI2. Then we get potassium iodide. Ki, Ki plus barium bromide. BaBr, BaBr. Okay. And what type of the reaction you have to write? Like no need to balance here. So what type of the reaction is this? What type of reaction? Double displacement reaction. Potassium is displaced by barium and both barium displaces potassium. Okay. So it is a double displacement reaction. It is a double displacement reaction. Next. Zinc carbonate, zinc carbonate. Next one, they've given zinc carbonate. Okay, when heated, we get zinc oxide plus carbon dioxide. Carbon dioxide. Try this. ZnCO3. You get ZnO plus carbon dioxide. Okay.
So if it says CO3 whole twice,
No, no. Zn?
CO3 whole twice.
No. Zinc valency 2. Carbonate group, its valency 2. Okay. Cross multiply, you will get one zinc combines with one carbonate group. Okay. And zinc oxide, zinc valency 2. Oxygen valency is also 2. Okay. You will get ZnO. ZnO plus carbon dioxide. ZnO plus carbon dioxide. This is correct. This only will come. Okay. Next. Next. Hydrogen plus chlorine. We get hydrogen chloride. Hydrogen plus chlorine. We get hydrogen chloride. Okay. Hydrogen H2, chlorine Cl2. We write hydrogen chloride is HCl. Okay. Hydrogen valency 1, chlorine valency 1. So we'll write it as HCl. So what type of reaction? Combination reaction. Second one, this one, decomposition reaction. Reaction. Okay. Done. Written. Next one, magnesium. Magnesium plus hydrochloric acid. Hydrochloric acid. We get magnesium chloride. We get magnesium chloride plus hydrogen. What is the answer? So if you know the valency and how we will write that, then it is easier to remember. Not get confused. It is MgCl or Mg2Cl or MgCl2 like that. No? If you know the valency and learn, so okay, MgCl2, yeah, this is the one because magnesium valency 2, chlorine valency 1. You will know. Okay. So magnesium plus hydrochloric acid is HCl. We get magnesium chloride MgCl2 plus the hydrogen gas. Okay. So magnesium valency 1, 2, chlorine valency 1, magnesium valency 2, valency 1 cross multiply, you will get MgCl. Okay, MgCl. So what type of reaction is this? Displacement reaction because magnesium displaces hydrogen. So it is a displacement reaction. Displacement reaction. Okay. It's done. Next, ninth one. What does one mean by exothermic and endothermic reactions? Give example. What do you mean by exothermic reaction?
Energy is reduced.
Energy is the reaction in which the temperature increases, then we call it as an exothermic reaction. Yeah, energy is also released. That is why it gets heated.
Respiration is
Uh, respiration is an example. Correct.
burning of gas. Burning of a gas.
Yeah. Okay. Combustion reactions. That is carbon plus oxygen, carbon dioxide. Combustion is mainly done for that only. No, we produce heat. So all combustion reactions are exothermic
But
reactions.
forming of water was exothermic. Forming of water.
I
Forming of
didn't.
water. Right.
H2O.
Yeah, is that exothermic or
H2 plus O2 you are asking H2O. That it is endothermic.
Now, if it is like from steam to water, then it's exothermic. If it's from water to steam, it's endothermic.
Endothermic, correct.
So, if it's from steam
And
to water,
see, that means actually all these decomposition reactions will be there. No, all the decomposition reactions are exothermic reactions. All the decomposition reactions are exothermic reactions. That is water, when you try to split, you have to provide the heat. Then it is an exothermic reactions. Sorry, endothermic reaction because you are providing the heat. No, it is an endothermic reaction. That is water, it splits into hydrogen and oxygen. Here you have to provide the heat. So it is an endothermic reaction. Okay, you have to provide the heat, and here it absorbs the heat. Because of that, it will split. So it is taking the heat. There it is endothermic. So combustion will be exothermic. Okay. What about the ninth one question? Ninth one question. Exothermic. Will you write the statement? Huh. So these the reaction in which heat is produced. So we call it as a exothermic reaction. Any example you can give. Okay, the respiration also. Next, endothermic reaction in which heat is absorbed. Uh-huh. That is also an endothermic reaction. Next, 10th one. Why is respiration considered an exothermic reaction? Why it is considered as an exothermic reaction? Heat is released or energy is released in this form. Hence, it is called as an exothermic reaction. And in our body also, the energy is utilized more to keep the temperature constant. To keep our temperature constant only, we use more energy. There we are using more energy, right? So energy is released. Energy is released whenever there is a respiration. That is, glucose combines with the oxygen to get carbon dioxide plus water, plus the energy is released. Write down that 10th one. Just write the the respiration is considered as an exothermic. It is considered as an exothermic reaction, as energy is released, in this process or in this reaction, as energy is released in this reaction. Okay. And here C6H12O6, that is glucose, plus the oxygen, we get carbon dioxide plus water plus the energy. Plus the energy is released.